Guys, so we're going to start up lesson 1.2 here today. We're going to do a couple things. I'm going to introduce you guys to the adding and subtracting rule for derivatives. We're also going to learn how to find the equation of that tangent line that we've been looking at. We've been finding what the slope of the tangent line is. We've been sketching the tangent line, but we haven't actually found out what the equation of that line is. And that's what we're going to do today. We're going to learn how to do it without a calculator, and we're also going to learn how to do it with a calculator. So today is a day where you're going to need a graphing calculator. Now, you can download them as an app on your phone. I recommend getting a TI-84. Now, you can download them on your phone, which would be fine if we end up doing the AP test online again this year, like last year, but I doubt that's going to happen. It could happen if we're still in some kind of a lockdown mode at that time, but if you're doing the test in person, they're not going to let you use a cell phone. You're only going to be allowed to use a real calculator. So obviously the best thing is for you guys to have your own calculator, and I recommend the TI-84. They're about $100, so it's quite expensive. School has some. I don't know when they're going to let you guys pick them up, or perhaps maybe you already have by the time you're watching this video. That'd be awesome. But you can get some from the school. But in the meantime, you can get an app on your phone. Just type in TI-84 emulator is the word you want to type in when you're doing your app shopping, and just TI-84 emulator and see what you can find. You want to find something that ends up giving you a calculator that it looks like it basically on your cell phone, it makes something look exactly like a calculator. If you're doing a lot of your work on your desktop computer, you can also do it from the internet. So instead, let me see if I can bring that up for you real quick. So if you guys go to ti.com, you could type in TI-84 emulator. Now, the problem with this one is these guys want to charge you money for it. So this one's not free. I don't know if it's more or less than the one you get for an app on your phone. The ones for the app on your phone, I've seen some that are free. I've seen some that cost a little bit of money. But anyway, here's a TI-84. So you would, that's for a smart, so I don't think it really matters. But click on one of these TI-84s here. I like this one up here that says the emulator software for the family, plus family. Click on that, and you can request a free trial. Now, it's probably only for a month long. I don't know. I mean, if you want to buy it, you can. The downside, once again, though, is that you can't use this when you're on the test. But the cool thing is about the apps or this thing on the computer is that, as you can see here, they actually give you a calculator. So I'll show you mine. I downloaded it. You can see what the buttons look like. This is pretty much what the calculator pad looks like, and this is what you would see on your screen. So it works for training you how to use the calculator, but when it comes to the test, you're really going to want to have a good old-fashioned calculator on hand. So anyway, so if you haven't gotten one of those yet, you might want to get on it or download one on your phone. But anyway, so we're going to go ahead and get started here on these objectives for today. So here's our newest rule that I'm going to be sharing with you guys. It's the adding and subtracting rule. Now, let's say I give you a function called h, and that function h is really just two other functions, or even more, being added or subtracted together. If you want to find the derivative of h, then all you have to do is find the derivative of each piece separately. So if h is equal to f plus g, then h prime is equal to f prime plus g prime. Okay, so that's pretty much it for the addition and subtraction rule. It's not that complicated. If you know the power rule already, it's pretty straightforward. So for instance, suppose I have this function here, y equals this crazy thing. Well, it's really just a bunch of little miniature power functions put together, right? So what we're going to do to find our derivative is we're just going to find the derivative of piece separately. So let's start off with this one. What's the derivative of 9x to the 4th? I'd multiply the 4 to the front, I would get 36, and then I would take 1 away from the power and get 3. And you're going to repeat that with the next one. The next one would be 9x squared. The next one would be 4x. This one, that is a constant multiple rule. Take a moment. What is the derivative of negative 5x? It's just negative 5, right? And this is a constant. What's the derivative of a constant? It's 0. So you really don't even need to read it or write it. It just kind of leave it off there. Notice the notation here. I put find dy dx and I wrote it like this. I guess that's fine, but maybe just to be consistent with the notation, I can write it the way that it asked for. But they mean the same thing, so it doesn't matter. But anyway, that's pretty simple. I'm not even going to provide a student practice for that because really all it is more of the same thing that we've already been doing. But I am going to move on to another type of example here that involves tables. So these are common questions as well in an AP calculus test. So right here in this table, they're going to give you some values for x. It looks like they've given us 1, 2, 3, and 4. And what they're doing here is they're telling me when x equals 1, f of x equals 2. Now, these are y values for the f function. So when x equals 1, y equals 2 for the f function. Or when x equals 2, y equals 4 for the f function. When x equals 3, y equals 2 for the f function, and so on. So those are the y values for the f function. But then they give you the f prime values. These are the slope values, or the instantaneous rate of changes, right? The IROCs, instantaneous rate of change. So when x equals 1, the slope of the function at that point is 2. When x equals 2, slope is 0. When x equals 3, slope is negative 3/2. And when x equals 4, the slope is negative 1. Okay? So that's what they're giving us for the f's, but then they move on and change the story a little bit, and they give us some information about another function called the g function. So here's all the y values for the g function. When x equals 1, y equals 3 for the g function. When x equals 2, y equals 2, and so on. They also give us the slopes, or the instantaneous rates of change for the g function for those same x values. So we have y values and slope values for two different functions. We have some y values and slope values for the f, and we have some y values and slope values for the g function. So now let's take a look at the question over here. The question gives us a new function. It says, let h be f of x plus g of x. They want us to find h prime of 2. Well, first of all, let's find h prime. Using our sum and difference rule, the derivative of h will be the derivative of f plus the derivative of g, right? All you do is to find the derivative of a addition function, all you do is take the derivative of each piece separately. So h prime is f prime plus g prime. But they also want us to find h prime when x equals 2. So now I'm going to plug in 2 to my h function. So if I plug in 2, it's going to look like this now. And now here's where the table comes in handy. We need to find out what is f prime of 2. In other words, we want to know what is the slope, that's what the little prime tells us, what is the slope of f when x equals 2? Well, here's the f prime, here's where x equals 2, and so the value that we're looking at is 0. So f prime of 2 equals 0. Let's do the same thing for the g prime. We want to find the slope of g when x equals 2. So here's g prime, here's 2. So the slope of g when x equals 2 is negative 1. And then we just go ahead and put those together for our final answer. H prime of 2 is equal to 0 plus negative 1, which is negative 1. There's our final answer. Okay, so step 1 is to take the derivative. I'll just put d for derivative there. Step 2 is to plug in. I'll put p for plug in. And then step 3 is to evaluate, which means just use the table to find out what each piece is. Okay, so that is how you can answer some questions using tables. Let's go ahead and have you guys try one of those really quick. All right, so here's one for you. You guys are going to do using this table here, which I'm not sure if it's the same table or not, but it looks like it might be the same table. But using that table, I want you guys to do this. Let h of x be f of x minus g of x, and I want you guys to find h prime of 4. Okay, so pause the video here and see if you guys can find h prime of 4. All right, so here's the solution. So our function was h of x is equal to f of x minus g of x. So the derivative of h is f prime of x minus g prime of x. We want h prime of 4, so we're going to plug 4 in for all the x's. And using our table, f prime of 4, I'm going to circle that in blue. F prime of 4 is the blue part here in the table. F prime of 4 is -1. And then g prime of 4, I'll do in purple here, that's the purple part on the table, is 1. So we end up with -1 minus 1, which is final answer, -2. Okay? And so that's how we can use the sum and difference rule along with tables to evaluate a derivative or find an instantaneous rate of change at a specific point. That's one type of question that we'll look at today. That's the sum and difference rule. So we talked about our objectives today was using the addition and subtraction rule for derivatives. We're done with that. We're going to move on to our second objective for the day, which is finding the equation of a tangent line. So as you guys know, we've been given functions, and we've also been spending a lot of time finding what is the slope of a function at a specific point, which is the slope of the tangent line, which is this little straight line that touches the curve at one single point. So our goal is we want to find the equation of that line. Now, since it's a straight line, it's going to take the form y equals mx plus b. It's a linear function. It's a straight line. So the equation of a tangent line will always look like that. And our goal is to find what is the equation of the line tangent to a curve at some specific point, the point of tangency. We're going to do it in two different ways, without a calculator first and then with a calculator. Let's go ahead and jump into that at this point in time. Before we do, let's review how to find the equation of a line. Now, some of you guys might have learned a way to do this in a lot of different ways, but I'm just going to go with what I believe to be the easiest way for our class here, which is to use this thing called the point-slope formula. It looks like this. Okay, so this one's obviously the m, and it's going to go right there in for the m. If you have a point and a slope, you should be able to find the equation of the line. So I've got a slope. I'm just going to plug it in there. The 3 is my x value, and the 5 is my y value, but they're we're going to call them x1 and y1. So I'm going to plug the 3 in right there for x1, and I'm going to plug the y1 in over here for y1. Okay, so let's go ahead and do all that. Erase all these lines out of my way real quick. So if I plug these in, I'm going to get the following. Now, before I go any further, I want to tell you guys something. On your AP test, you're going to have two types of questions. You're going to have free response questions and multiple choice questions. For a free response question, this is good enough. You don't need to simplify when it comes to a free response question. And in fact, if you do, you're only going to make things worse for yourself because it's possible you're going to get the answer wrong. If you stop here, you get it right. But if you try to simplify it and you do that wrong, then you actually lose the entire point. So on free response questions, you would stop here. But for multiple choice, they're not really going to stop there very often. For multiple choice questions, you have to choose between a certain set of answers, and they're probably only going to be in simplified form. So I'm going to go ahead and simplify this one. But just keep in mind that for free response questions, you don't have to simplify. So the first thing we're going to do is we're going to distribute that 2/3 in. Now, 2/3 times 3. How do you do that? 2/3 times 3. We'll put that 3 over 1. In this case, the 3's cancel. You're left with 2 over 1, which is 2. That worked out nicely. Unfortunately, sometimes you might end up with fractions there. That can happen. And then we're going to go ahead and combine our like terms. So -2 and 5 makes 3. So that would be the equation of a line that has a slope of 2/3 going through the point 3, 5. Okay, so if you have a slope and a point, you're good to go. So 3, 5, there's the point 3, 5. 2/3 would be up 2 over 3. So rise 2, run 3, put another dot. That's my straight line, and that's the equation of that line. That's all. That's actually all Algebra 1 stuff. You probably did it in geometry. You probably did it again in Algebra 2. So hopefully this isn't looking too weird and foreign to you guys. But that's how you find the equation of a line. You're going to use this formula. Nice little formula. Make sure you have it written down somewhere. Well, it turns out that finding the equation of a tangent line is the same thing. You need a slope, and you need an x, and you need a y, and you're just going to plug it into this formula. So here's how you do it. First of all, find the y if necessary. And a lot of the problems I'm going to give you, I'm only going to give you the x value. In this case, I'm saying x equals c. So find the y value if necessary. The way you do that is just plug the x into the original function. I'm going to write the word original here. Not the derivative function, but the original function. So plug the x value into your original function. That'll tell you the y value. The next thing we want to do is we want to start finding the m value. So to do that, the first thing you got to do is find the derivative of your function. And then you're going to find the slope by plugging x into the derivative this time. So if you plug x into the original function, you get the y value. But if you plug x into the derivative, you get the slope of your tangent line, the instantaneous rate of change of the function at that point. So now we have everything we need. I will always give you the x value. You may have to find the y value sometimes. Then you're going to have to find the m. So you'll have the x, the y, and the m. You're just going to plug it in here and simplify if you want to. I'll say it's optional. And you're all done. You've found the equation of the tangent line. So it's pretty straightforward. Let's go ahead and do an example just to make sure those steps come to life for you a little bit. So here we go. This is our first example of finding the equation of a tangent line. This one's going to be without a calculator. Okay. Now notice I put here, this is not in your notes. The notes I printed out are from last year, and every year I like to make some changes. And so this is one of those changes. So if you're not seeing it in your notes, no, you're not going crazy. It's because it's not there. I would definitely write it down on the back or something and include it though, okay? So find the equation of this line that's tangent to the, find the equation of the line tangent to the function that looks like that at x equals 2. Now, I'm going to give you like a little pretend picture. That graph, f of x there, it's going to be like an upside down parabola. I don't know exactly where it's going to be located, but it's going to look like that. And we want to find what's the slope at x equal, or what's the equation of the tangent line, at x equals 2. So here's where x equals 2, and here's the tangent line at that point. I want to find what is this equation of that blue line. Okay? Now you guys might be wondering, why the heck do we even care about that? Well, actually later on it turns out that that's a very useful thing to know. It helps you know all sorts of things about your function that's very useful. And we'll see how that's useful when we get to chapter 4. But until then, for now, we just want to make sure you know how to do the steps. Just to let you guys know, this is a very important topic in AP Calculus. You'll definitely see it on your AP exam. It's definitely something you want to make sure you know how to do well. Okay? So let's go ahead and begin. So the first thing we need is we need an x value, right? Well, they gave us the x value. The next thing we need to do is we need to find our y value. The way that you do that, according to the steps on the last page, is you're going to plug the x value that I gave you, which in this case is 2. You're going to plug that into the original function. That's this thing here. So let's do that. Careful with your order of operations here. Exponents come first. And then you do your multiplication. And finally, you do your addition, and that's left to right. So negative 12 plus 8 is negative 4, And if I take 5 away from that, I get negative 9. So my y value is negative 9. Okay, so the last thing, well, not quite the last thing, but pretty close to the last thing, is we need to find the slope. The way you do that is you find the derivative of your function. And here's where the calculus comes in. We need to find the derivative of this function here. So let's do that. Now notice we have a sum of powers here. So I'm going to do the power rule in the first one. I'm going to multiply the 2 to the front. And that's going to give me negative 6x, and then take 1 away from the power here. So we're left with a power of 1. Now we're going to take the derivative of this one. Now this is a constant multiple rule when you just have an x here. The derivative of an mx is always just the m. So that's going to be 4. And this is a constant. So the derivative of a constant is always 0. You could write plus 0, but I'm not going to. It's a waste of time. So that's my derivative. So step 1, find y if necessary. We did that. Step 2, find the derivative. We did that. Step 3, plug the x value into your derivative. And that's going to help you find the actual slope at that point. So negative 6 times 2 is negative 12. Negative 12 plus 4 is negative 8. And so there's our m value, our slope. Okay, so we have everything we need then. We have our x value. We have our y value. And we have our slope. And now the problem becomes exactly like the last thing we did on the last page. So we move on to the next step, which is just go ahead and plug it into this point slope formula is what this thing is called. It's called the point slope formula. So here we go. Y is equal to negative 8, my m, x minus x1, which is 2, plus y1, which is negative 9. So simplifying this, you don't have to. You could leave it like this, but I'm going to go ahead and simplify. We distribute the negative 8. Plus a negative is the same thing as just minus 9. And then combining the 9 and the 16, we end up with 7. And there's the equation of the line that would be tangent to this function at x equals 2. In other words, the picture I drew for you a little while back looked like that, right? Well, what we just found was that the equation of that straight line is y equals negative 8x plus 7. Okay, so there's your steps. So I would go ahead and encourage you to try the student practice I'm going to show you right now. Go ahead and pause the video and see if you guys can find the equation of the line tangent to this function when x equals negative 1. Okay, so I've got the answer here in purple down there in the bottom right corner. You can see the final answer. Now, if you didn't get that, you might want to go ahead and go through the steps here with me. If you did get that, go ahead and just fast forward to the next problem. But if you didn't get it, let's go ahead and go over it. So first of all, I identified the fact that x equals 1, right? That's the point of tangency. Oops, lost my slide. That's the point of tangency. Next, we want to find our y value, so we plug negative 1 into the original function. You got to watch your order of operations. Negative 1 to the third power comes first. That's a negative 1. Then you do your multiplication. Negative 1 and 2 makes negative 2. Negative 8 and negative 1 makes positive 8. And then combining your like terms there gives you 6. So the y value is 6. Next, we move on to finding the slope. So we find the derivative first of the function given to us. The derivative is 6x squared minus 8. Next, you're going to plug in negative 1 for the x value to find the slope. You plug it into the derivative, though, this time. So powers first. Negative 1 squared is a positive 1, and positive 1 times 6 is 6. So we end up with 6 minus 8, which gives us negative 2 for our slope. So my y value is 6, and my slope is negative 2. So I'll write that up here. We had negative 1, 6 for the point. And for the slope, we had -2. And you're just going to plug it into this formula now. Got to be careful here. When you plug in a -1, you have minus a -1, so it actually becomes +1. Then you do your distribution and combining like terms. You get -2x plus 4. And that would be the equation of the line that's tangent to this function at this value of x. Okay? That's how you do it by hand. Let's go ahead and move on to doing it on a graphing calculator. Now, some of you guys might be tempted at this point to say, well, I don't have my graphing calculator, so I guess I just won't do it. Well, I showed you guys in the beginning how you can get some on your phone. You can also get one off of online. If you don't do this now, you're going to not remember how to do it when it matters, and then you're going to have a hard time. And remember, I told you this is very important on your AP exam, so you want to make sure you know how to do this. So if you don't have one, make sure you get one now and follow along the steps with me. Here we go. So I'm going to be coming back to this page intermittently, but we're going to be doing 4 things. I deliberately made this look really ugly. Okay, I did that on purpose because we're going to use a calculator. If I made it look pretty, you'd probably just do it by hand and skip the whole calculator thing, right? We're going to go ahead and graph this function first, so I'll show you how to do that. We're going to find f of 2. Now, just so you know, that's the y value. So I'm giving you an x value. The x value I'm giving you in this case is 2, because that's what we're plugging in for x, right? And the answer that we get after we plug it into the original function is going to be our y value. Then we're going to find the instantaneous rate of change at x equals 2. Now, that's just a fancy way of saying find f prime of 2, or in other words, the slope. Okay, so same steps. We're plugging into the original to find the y. We're plugging it into the derivative to find the m, or the slope. And once we have that, we can have a tangent line. Then we're going to go ahead and graph that as well on our graphing calculator. So what's cool about this one is you're actually going to have a picture now at the end. When you're all done, if your outcome doesn't actually look like a straight line touching a curve, then you have a problem. Okay, so on your calculator, this is what your keypad will look like, and this is what your screen will look like. Now for me, I have a key press history down here, so if you guys want to see what buttons I've been pushing, you can watch me push them over here on the keypad, of course, but it keeps a record of what I've typed here. But if you guys ever want to clear your calculator, you're going to push the following combination. You're going to push second plus 712. And it clears out your entire history. So I'm gonna go ahead and type that again for you. So second plus 712. If you press that sequence of keys, it completely clears out your calculator, anything you've stored in there, so that it's all nice and clear and ready to go for your next thing. All right, so the first thing I want to do is I want to tell my calculator what the function is that I'm working with. Now, the first thing I'm going to do is I'm going to rewrite this function a little bit first, because sometimes calculators will let you do this radical notation, but it's a lot easier if you just change them to power notation, which means I would rewrite it like this. Now, you don't even have to write this by hand if you don't want to, but that's how we're going to type it into the calculator. So let's go ahead and type that into our calculator. So the first thing I'm going to do is we're going to push y equals. This is where you can store functions into your calculator. So you could put as many functions as you want to in here. For right now, we're just going to put that first one in. So it's going to be 6. I'm going to press 6. Let me clear out my history here a little bit. I'll start over. We're going to type 6. And then we're going to push X. That's this button right here. And then we're going to do the power button, because I want this to be x to the power 5/3. So this little arrow right here is called a caret symbol. If you press that, it will give you an exponent. Now, some calculators actually just put an arrow right here. That's fine. I like calculators like this, though. They actually make it look like an exponent at this point. You don't always have to do this, but it's not bad practice. Anytime you're typing in a calculator, put it in parentheses if you're going to type a fraction in your calculator. So we're typing in 5/3. So I'm going to put 5 divided by 3, close parentheses. On this calculator, it really wouldn't have mattered if I used parentheses or not, but if you had the one where it actually puts the little arrow caret symbol here instead of making an exponent, you would actually need those parentheses, okay? Now, if you have one like mine where it actually does go up in the exponent at this point, you're going to have to push this arrow key to get out of the exponent. If you don't have a calculator that writes it like this, it just uses the caret symbol, you wouldn't have to do that at this point. So long as you put it in parentheses, you'd be good. But anyway, now we're back out of the exponent. The next thing I'm going to put is minus 5x. And you know what? I just realized something. I'm going to go back to this page. I know this said plus, but I actually forgot to change it. I'm going to make it minus 5x. Okay, it's minus 5x. So there's my function. Okay, now if you guys go ahead and push graph, this button right here, it will actually graph the function for you. Okay, so that's what that function looks like. Now, that's the first step of the problem. It says to graph the function. Now they want us to find f of 2. In other words, what's the y value when x equals 2? Well, let me show you how to do that on a graphing calculator. There's a few ways to do it. The way we're going to do it right now is you're going to push this button here that says second. So let's do that. You're going to push second, and then you're going to press this button that says trace. And since we pushed the second button, actually what we're doing is we're doing this button up here, which is called Calc. So push trace. And it gives you a bunch of options. We're going to choose 1. Number 1. That's the one that says value. That's a y value that we're looking for. So we're going to type in the x value that we want to work with. The x value I'm plugging in is 2. So we're going to type 2 and enter. And it's going to tell you the y value that goes with it. And it actually puts a little cursor right there on your graph as well. So where that cursor is blinking, that's where x equals 2, and apparently the y value is 9.048. And just so you guys know, in AP Calculus, we always round to the third number after the decimal, which is the thousandths place. So since this is an 8, I'm going to say that y is equal to 9.04, and I'm rounding that last number up to 9, since the number after it is 5 or bigger. So that's going to be the y value that I use. All right. So that's this step here. We graphed the function. We found the y value. Now we want to find the instantaneous rate of change. In other words, I want to find what is f prime of 2. What's the slope of my function at x equals 2? So let's go over to our calculator. Once again, all you're going to do is you're going to push a pretty similar sequence of buttons here. You're going to push second, trace, which is the calc button, and look for where it says derivative. That would be option 6, as you can see there, option 6. So go ahead and push 6. And now we're going to type in the x value that we want to find the derivative for. So we want to find what's the derivative when x equals 2. So let's type 2 and then enter. Now, it gave me the y value also. If yours gives you the y value when it gives you the derivative, then you really only have to do that step. You don't have to do the y value first and then the derivative. It could do both for you. However, on a lot of calculators, especially ones that I know you guys can get from the school, you actually have to do them separately. So that's why I did it in 2 separate steps. But anyway, right here is your slope, 10.87401. So I'm going to write that up here. My slope is 10.874. And I'm going to stop at that third number after the decimal. And this time I'm going to keep it as 4 because the number after the 4 is less than 5. Okay? And so we have everything we need. We know the x value we're working with is 2. We know the y value is that. We know this is the m value, which means that I also know now that the equation of this line would be as follows. Y equals 10.874 parentheses x minus 2 plus 9.049. And that would be the equation of my tangent line. And so I'm going to go ahead now and I'm going to do the last thing that the instructions asked me to do, which is to graph the tangent line. So let's do that as well. So we're going to go ahead and go back to this y equals button now. So go ahead and push y equals. And go ahead and push the down arrow to get to y2. And we're going to type in this expression down here, which is the equation of the tangent line. So it's going to be 10.847 parentheses x minus 2. And by the way, you have to be very careful when you're typing these things in. This button down here is a negative button, and this button right here is a minus button. For us, the way we treat them is usually the same, but in a calculator, it will confuse your calculator. This is a negative, this is a minus. I want x minus 2. So make sure you push this button. If you got an error symbol at any time, that very often is the mistake that people are making. So we have x minus 2, close parentheses, and then plus 9.049. And go ahead and push graph once again, and there's the tangent line. And so, as you guys remember, the point of tangency was somewhere up here. So this red line is my tangent line that is touching the actual function at the point x equals 2. And that red line, the slope of that red line is the tangent line. The slope of that red line, which is this, represents the instantaneous rate of change of the blue function at that point, x equals 2. Okay? And so there it is. So that is how you use a calculator. A lot of steps in there. Takes some practice probably, but that's okay. That's what we're here for. And it's actually very fast once you get used to the steps. So I'm going to give you guys a student practice here and let you guys go ahead and try this problem. So go ahead and pause the video and see if you guys can work this out. And then when you unpause it, I'll walk you guys through the process. Okay? So the first thing that you want to do is you want to rewrite this as 2x to the 1/3 power plus 2x squared minus 3x. Now we're going to go ahead and type that into our calculator. Before I do, I'm going to clear out what I did last time though. So I'm going to push second plus 712 to reset my calculator. I'm going to push y equals, and we're off. So it's going to be 2x to the power of 1/3. And then after that, it's plus 2x squared. And by the way, if you're just doing a power of 2, you can use this button instead over here. Save you a little bit of time. And then after that, we have minus 3x. And remember, it's not negative 3x, it's minus 3x. So if you got an error, you probably pushed the negative button instead of the minus button. Okay? And go ahead and push graph, and we'll give you a function right there. All right, so that's step 1, graphing the function. Now they want us to find f of 1, which is our y value. So we're going to push second, trace, value, enter 1 for x, and my y value is 1. So that's nice and convenient. My x value is 1, that's what I'm plugging in, and by plugging that in, I got y equals 1. Now we want to find the slope. So now we're going to push second, calc, or trace, and 6 for dy dx, the slope. And this time we're going to type the x equals 1 again, and it will give us the slope, which is 1.6666668. We're going to round to the thousandths place, so this is going to be 1.667. And that means that my equation of my tangent line will be the following. And so let's go ahead and graph the equation of the tangent line. So we're going to push y equals. We're going to go down to the next equation, And we're going to type that in, 1.667 parentheses x minus 1 plus 1, and then graph. And as you guys can see, my point of tangency is right here at 1, 1, and my red line is grazing the function at that point. So that red line is the tangent of this function here at x equals 1. And the red line slope represents the instantaneous rate of change of this curving function. And that's the end of our lesson, and we'll see you guys next class.